So already see the way you can have to make use of the Newton's third law of motion as well as the Newton's second law of motion for the system of the contact bodies. So now, what are the contact bodies? Let's say this is a body of, let's say, a mass 1, and we have another body, let's say a body with the mass 2. Let's say the bodies are in contact. So now, assuming that the surface is frictionless, which means it brings no resistance to the motion of the actual system, the bodies. So now, let's say we have a force being given as, let's say, F. That should be just being given as F, being exerted on the body of mass 1. So, if it happens that the force being exerted surpasses the weight of the combination of the two actual bodies, we'll see that the system of the bodies will have to move towards this direction. Let's say the bodies are to accelerate along x-axis towards this direction. That's what will happen. But what is really the principle behind the motion of the body that are in contact if this is the case? So now what will happen is that as the force given as F has been applied into the object of mass m, now the object of mass m is going to exert the force towards the object of mass. Actually, if we apply the force on the object of mass, actually m1, then a mass m1 is going to exert the force onto the mass given as m2. Let's say the force has to be given as, let's say the force has to be given as, given as F2, actually should be given as F1. Now, according to the Newton's third law of motion, now a body 2 is going to exert the force back onto a body 1, and the force will be given as that. So let's say we should have it as F2. But at the end of the day, you see that the system of the bodies is going to accelerate towards this direction. That's what will happen. So which means if we apply the force on the object of mass 1, and the object mass 1 will exert the force on the object of mass 2, and the object of mass 2 is going to exert back the same force towards and against the F1 and onto the object of mass 1. That's what will happen until the objects are to move. So that's the principle behind that. Now, since the surface is assumed to be a frictionless surface, it means both objects are going to accelerate at the same rate because the surface is frictionless. So both objects are going to have the same acceleration. So keep that in mind. So what is the contact force between the two bodies? So now the contact force is the reaction force, and the contact force will be given as now F2. That will be the reaction force. So F2 will be given as a mass 2 times the acceleration. So that's how the contact force will be obtained. So keep that in mind. So now, which means, let's say if it happens that let's say the object of mass m, let's say mass m is greater than, let's say, a mass 2. So what will happen is that the contact force will be less. So the contact force F1 now should be the contact force will be actually less, because the contact force will be the force F2 that will be obtained from the product of the mass 2 times the acceleration. And where if it happens that the m1 is less than the m2, what happens is that the contact force F2 will be given as that of M2 times acceleration. So since M2 is less than M1, it means we'll have the less contact force compared to actually this case. So which means if the upright force is on the object with less mass, that means the contact force will be great. And if the upright force is on the is being applied on the object with more mass, it means it means the contact force will be actually less. So keep that in mind. Now what if we have the system of, let's say, several contact bodies? Let's say we have this case, and I also have another case here, and let's say this is another case, and also let's say this is another case. Let's say that's the way out. So in this case, let's say the force given as, let's say, F has been applied onto the object of mass 1, mass 2, mass 3, let's say a mass 4. Let's say the force has been applied onto the mass, actual object of mass, actually mass 1. So now assuming that the surface is frictionless, it means the system is going to move towards this direction at the same constant rate. Thus, acceleration will be the same for all objects. So now let's have to analyze the force systems and for the system of the contact bodies as we have it here. So what will happen is that the mass of M1 is going to exert the force onto the mass of M2. Let's say it will be like that. Let's say given as let's say should be given as F1. So which means the mass M2 is going to exert back the force onto the M1 that let's say should be given as F2. Now at the same time, a mass 2 is going to exert the force on the mass 3. Let's say should be like this. And let's say should be given as F3. And what will happen is that the mass 3 is going to exert the force back onto the mass 2. Now we should have it as, let's say, F4. At the same time, a mass 3 is going to exert the force on the mass 4. So what will happen is that we'll have it as like this. Let's say given as F5. Now at the same time, a mass 4 is going to exert back the same force. It's going to exert back force on the mass 4. Should be on the mass 3. That will be given as this. Let's say have it as F6. So that's how the force systems will be for that kind of a system. So now which means if we exert the force on the mass actual 1, the mass 1 will exert the force on mass 2, that is given as that. According to the Newton's theory of motion, mass 2 will exert back the force on the mass actual 1. And at the same time, mass 2 will exert the force on mass 3, and the mass 3 will exert back the force given as F4. And you will keep on having that way. So keep that in mind. So what is the contact force between M1? Rather, what is the contact force between the M1 as well as M2? That is the contact force between the two objects here. Now, the contact force or the reaction force in which actually M1 is going to experience will be due to the influence of the rest of the masses. So which means the contact force given as F2 will be given as the summation of the forces, the summation of the forces for mass 2, mass 3 as well as the mass 4. That will be the contact force in the sense that we have it as acceleration AX times mass 2 plus mass 3 and plus mass 4. This will give us the contact force between the mass actual 1 as well as the mass 2. Now how about the contact force between, let's say, mass 2 as well as the mass 3? Let's say in this case. So the contact force will be given as the reaction force, which is given as the F4. And it will be due to the influence of mass 3 as well as the mass 4. So in that case, we have it as the acceleration AX times mass 3 and our plus mass 4. So keep that in mind. How about the contact force between, let's say, mass 3 as well as the mass 4? So the contact force will be now being given as this. So the contact force between mass 3 as well as the mass 4, we'll have it as, now it is the reaction force which is given as, should be F6. So F6 will be given as acceleration, that is AX. Now should be just that of a mass 4 times acceleration, because we only have the single mass in this direction. And now if we had looked at the reaction force at this point, so which means we only have the single actually mass, which is M4, and that is remaining over there. So that's how the contact forces are actually obtained in that case. So now which means the reaction force in which M2 will have to exert on the actually M1 will be due to the combination of the actually 3 masses. Likewise, the reaction force in which the M actually 3 will have to exert on the actually M2 will be due to the influence of M3 as well as the M4. So that's what happens whenever you are pushing the bodies that are in contact. So now try to go through, try to Google it out, some of the applications of the contact bodies in a real life situation. So try to go for that. So now let's say we have the body, let's say this is the body of, that should be, this is the body of mass 1. And let's say we have another body, let's say this is the body of mass 2. Let's say this is the case. So now assuming that we have a force given us, let's say F, and let's say the force is given us 2000, it should be 200 newtons. Let's say this is the 200 newtons force, and it is being applied into the object of mass M. Let's say the object of mass M is having the mass of, let's say, 50, should be 20 kgs. Let's say that's the case, and this one is having it as, let's say, 10 kgs. Let's say that's the case. So now assuming that the surface is a frictionless, what is the contact force between M1 as well as the M2 as well as the acceleration of the system? Now how should you be able to go over that? So now first thing, we should have to highlight all the forces in action. So as we are to actually push this object of mass M1, the object of mass M1 will exert the force onto, let's say, M2 given as F1. And the Newton's third law of motion also make it possible that the M2 will have to exert back the force, let's say, onto the M1 given as, let's say, F2. That's what will happen. So now let's have to analyze the forces acting on each body separately. So we have the force, we have to go for M1. So what is the free body diagram for the system of the forces acting on the M1? Let's say now this is the free body diagram, and now for the actually M1. So mind you, the free body diagram is presented as now as a point particle that represents an object. So, and also with the forces acting on that actually particular object. So what are the forces acting on the object, or should be on the mass M1? So we have the force, now we have the force given as, now should be F, which is this. And we also have the reaction force, which is F2, now which is acting on the object as well. And it is going like this. This is the F2. So these are the forces acting on the object M1. So we have F2, that's the reaction force acting onto this one. And we have this force applied acting onto object of M1. So now it happens that at the end of the day, the object is moving towards this direction. So which means F2 is acting against the direction of the motion, while the applied force is acting in the direction of the motion. So now according to the Newton's second law of motion, these forces are the ones responsible for the motion of the object. Hence, we should have to understand that the summation of forces are equal to mass of object 1 times acceleration on x-axis. So what are the forces acting on the actual object of mass 1? We have the applied force minus, that is F2. Now it is minus because it is acting against the direction of motion. Is equal to mass 1 times acceleration. So what is the applied force? We have it as 200 minus F2, and is equal to, what is the mass? We have it as 20 times acceleration. And of course this is the same as having it as negative F2. Now we should just have it in this way. We can have it as, now have it as 20 should be 200 minus F2 is equal to 20 times acceleration. And of course we already have it. So now which means this is, now should be, this is equation 1. So take note of that. Now let's go for the analysis on the forces that are acting on the object 2. Now we'll have now about M2. So what are the forces acting? Now this is the free body diagram, and we only have the single force acting on the M2, which is given as F1, and it is acting in the direction of the motion. We have it as F1. So which means according to the Newton's second law of motion, that is the only force responsible for the motion that is given as that. So now which means we'll have F1 being given as, now what is F1? So which means we'll have it as a 10 times acceleration. So this is equation number 2. Then we should have to solve for acceleration. But since we have two actually equations there, so we have 200 and minus F2 is equal to 20 acceleration, and we have F1 and is equal to 10 times acceleration. So now according to the Newton's third law of motion, these forces are the same but only they differ in the direction. So that corresponds to have it as, we should have to add the two equations, and we'll have to remove those. We'll have 200 is equal, now have 30 times acceleration. So what is the acceleration? We'll have it as 200 divided by 30. We'll have that understand that corresponds to have it as 20 over 3. That will be the acceleration, meters per second square. So that's how the acceleration will be obtained. So what is 20 divided by, should be 3. Now the 20 divided by 3, that should be 20 divided by 3. We'll have it as 6.7. So which means we'll have acceleration being given as 6.7 meters per second square. That's the acceleration. And how about the contact force? So keep in mind that the contact force is the same as the reaction force. So the contact force is given as F2, which is equal to mass 2 times acceleration, which is given as 10 times acceleration 6.7. Now should be that, we'll have it in newtons. So that's how the contact force will be obtained in that way. Take note of that. So what if we have this kind of a system? Let's say we have these bodies. let's say this is the case. So now assuming that this is the body of, let's say, a mass 1, this is mass 2, this is mass 3, this is the mass 4, in that way. And let's say the mass 1 is given as 50 kgs. Let's say this is, let's say, 20, this is 10, let's say this is 200 kgs. Let's say the force given as, let's say, should be 3000 newtons has been applied into the object of mass actually 1. And assuming that the surface is frictionless, what is the acceleration along x-axis and the contact forces between m1 and m2, m3 and m2, and also m3 as well as the m4? How should you go over that? So now let's think of having the analysis of the forces acting in the system. Now we have the force, let's say F1, actually mass 1 have to exert on the mass 2, and mass 2 have to exert the back the same given as F2, and I'll have mass 2 exerting the force F3 onto M3. M3 also have to exert the back given as F4, and I'll have F5. Now that is mass 3 exerting onto the actual mass 4, and the mass 4 will have F6. So take note of that. Now let's go for actually mass 1. Now this is the free body diagram. We have the force given as the applied force, and we have the reaction force acting on it given as, that should be F2. So which means according to the Newton's second law of motion, we'll have F2 minus F1 is equal to mass 1 times acceleration, of which we have 3000, and minus F1, which is equal to 50 times acceleration. Now this is given as the equation 1, so keep that in mind. And let's go for the system of, let's say, a mass 2. So on the mass 2, we have the free body diagram, and the forces acting, we have, now should be, we have F1 acting on it given as F1, and we have that of F4 acting on it. So according to the Newton's third law of actually a second law of motion, which means we'll have F1 minus F4, which is equal to mass 2 times acceleration. So which means we'll have it as F1 minus F4 is equal to 20 times acceleration. Now this is equation number 2. Keep it safe. And now let's go for the system of, let's say, a mass 3. So the free body diagram for mass 3 will have the force given as, now should be, we have the force acting in the direction of motion, and given as, now should be F3, and now we have the force that is acting against the direction of motion, that is given as, now that should be F6. So take note of that, because F3 is acting onto the actually a mass 3, and in this direction, that is given as that, and F factor 6 is acting against the direction of the motion, and which is given as this. So take note of that. So according to the Newton's second law of motion, we'll have F3 minus F6, which is equal to mass 3 times acceleration. That is the same as F3 minus F6 is equal, no, should be 10 times acceleration. This is equation number 3. Now keep it safe. And let's go for the system of, let's say, mass 4. So we have the free body diagram that will be looking at this. We only have the single force acting on the mass 4, that is F5. And according to the Newton's second law of motion, we have F5 is equal to mass 4 times acceleration. That corresponds to have it as F5 is equal to 200 times acceleration. This is the equation should be that of number 4. So take note of that. Now we have almost 4 equations. That is 3000 and minus F1 is equal to 50 times acceleration. We have F1 minus F4 is equal to 20 times acceleration, and we have that of F3 minus F6 is equal to 10 times acceleration, and that of F5 is equal to 200 times acceleration. Now we should have to add the 4 equations. Now what happens is that actually F1 and F2 are the same, then they'll cancel. Then they're going to cancel in that way. F1 has F2. Now what will happen is this. Where is the F2 in the equations? So this will be given as F2. Here should be given as F2 rather. We should have it as F2. So which means F2 as well as the F1 are going to cancel. And also F4 and that of F3 are going to cancel, because they are the same, that they are different. Actually, they are different directions according to the Newton's third law of motion. So which means we now have it as, now should be like this. We'll have 3000 is equal to, we'll have to sum up this and solve for acceleration. Upon having the acceleration, all we need is to have, upon having the acceleration, then we'll be able to have, so now upon having the acceleration, then we'll have to find the contact forces between M1 as well as M2, of which the contact forces will be, let me just have to have it this way. Now the contact forces, let's say between M1 as well as M2, we'll have it as F2. That will be equal to the acceleration that will be obtained times the summation of this 4, actually this mass as well as that mass. And how about the contact force between M2 as well as M3? Will be given as the F4. That will be given as the acceleration times the sum of this mass as well as this as well as that mass. And how about the contact force between, let's say, M3 as well as the M4? Will be given as F6. That will be given as F6 is equal to mass 4 times acceleration. So that's how you have to understand that one up to, in order to have the contact forces acceleration in that way. And sometimes you can also have to incorporate the equations of kinematics, where upon having the acceleration you can be able to have the initial velocity, final velocity, also the time takes as well as the distance covered. That's based on the nature of the question that we have. But the how you have to understand about the principles behind the analysis behind the contact bodies, and by using the Newton's second law of motion as well as the third law of motion. Thank you.